Okay, this is our presentation on thin layer chromatography.
So then in this presentation, we're going to talk about what it is, how it works, the steps to perform this procedure, and also common problems that you may encounter with this. So what is TLC? TLC stands for thin layer chromatography, as you said earlier, and this is a way to assess the purity of a substance and see if a reaction is completed or not. And it does this by separating components similar to how paper chromatography works, and it is also generally pretty fast depending on the substance. It can be as fast as say 5 minutes. So how it works is, like I said earlier, that it is similar to paper chromatography, and it works by measuring the movement of the compound on a TLC plate. And in order to view this, you'd have to use a UV light because generally organic compounds are colorless. And in order to determine if it's finished or not, you use a retention factor, which is an RF value, and you find this by dividing the distance traveled by the compound by the distance traveled by the solvent front.
So the steps that you're going to do in lab to perform this experiment. First thing that you're going to do is you're going to take your TLC plate and you can cut it to the correct size to fit in your developing chamber, which you can use just a regular beaker. And then you're going to draw a line 1 centimeter from the bottom of the plate in pencil. The next step is you're going to use TLC pipettes to apply spots of analyte along the pencil line. And then you're going to fill the developing chamber with solvent, and you're going to make sure it's just enough to cover the bottom. Then you're going to evenly place the plate into the chamber, and then you're just going to wait and watch the solvent drop up the plate. Then the next step is you're going to remove the plate from the chamber once the solvent is roughly 1 centimeter away from the top, and then you're going to draw a line in pencil at the front of the solvent. And then your last step is you're going to use UV light to visualize the spots. So some common problems that you might run into when performing this experiment. You might get over large spots. Spots shouldn't be larger than 1 to 2 millimeters. Another common problem is an uneven solvent front. That could be caused by not enough solvent, or if the plate wasn't evenly put into the developing chamber, or if you unevenly cut the plate. So it's recommended to use a ruler when you're cutting the plate. Another problem is streaking, and that can be caused if the sample spots were too concentrated. And then a final problem is if you don't see any spots, then it's possible that your solvent level was above the line that you drew, above the above the drops of sample analyte that you placed on the and these are our references for our reference.